Okay, today I'm going to cover 11.6 applications of trigonometric functions. So before I begin, I've just drawn an example for you of a sinusoidal curve here. So this is a sinusoidal curve, and it can be represented by this function over here. Now, the thing here is this: there are values a, b, and c. I just want to give a quick recap on how I get some of these values. So first is the A. So what I get from A is this. I see there's a central line, okay, running through the graph. So how far does the maximum and the minimum deviate from the central line? You can see here it deviates as 5 and 5. So in this case, what I can say is that my A value is the amplitude, okay, so the maximum displacement, okay, from the central line is 5 units. Hence, for my graph here, y is 5 sine bx plus c. The next idea I want to just regurgitate is about the period itself. So period, what is period? Period is how long it takes for the graph, right, to repeat one full cycle. So for example, for a sinusoidal graph, from here to here is one full cycle, okay, and for this example, it is 4 pi. So as you can see from here, period is equals to 360 over b, okay, or the period can also be equals to 2 pi over b. If you notice, since we are using in terms of pi here, I'll be using this period of 2 pi over b. So the period here, the time it takes for it to repeat one full cycle is 4 pi. So I say 4 pi is equals to 2 pi over b. So b equals to 2 pi over 4 pi. My b value is half. Hence, I'll say y equals to 5 sine half x plus c. C is the displacement of the graph by right. Okay, if you see here, or it can be seen from the axis of the graph, the sine graph should start at 0, but now the graph has shifted. It should be like this. It's now shifted upwards. From 0, it's shifted up to 15. So my c value itself is equals to 15. So my graph here gives me 5 sine half x plus 15. So that is how I actually use, these concepts here to get the amplitude, the period, and the what I call the c value itself. Just before I carry on, there's one more thing that I want to say. Period doesn't necessarily mean, right, one complete cycle in the sense that you can see it. For example, one complete cycle can be like this. Another way of seeing a complete cycle is from peak to peak. So this itself is also one complete cycle, and this will give me 4 pi as well. Okay, similarly, from the trowel to trowel, the bottom, okay, here to here, this will also be 4 pi, okay, the period as well. So instead of just seeing one complete cycle in this sense, you can see it from peak to peak, okay, or it can be from trowel to trowel. That will also be 4 pi, or the period in this case. Okay, now what I'm going to do here is this. I'm going to explain example 22, which can be found in your textbook. So you talk about the motion of a Ferris wheel. So the radius of 10 meter is 1 meter above the ground. All right. So they want us to form a trigonometric function to model the height of the capsule above the ground as a function of t seconds. So I will start first, okay, with y is equal to a sine, okay, bx plus c. Okay, so if the radius of the wheel, all right, is 10 meters itself, so what I can say is here to here to here, okay, the central line is here. So the maximum displacement from the central line is 10 meters. Here to here is 10 meters. So therefore, my a value immediately is equals to 10. Next thing is to find the period itself. So in this case, they say the period is 40 pi seconds. So one complete cycle gives me 40 pi seconds. So from what I know is period is equals to 2 pi over, the period, the period is equals to 2 pi over b. So in this case, our period is 40 pi equals to 2 pi over b. So solving, my b value is 1 over 20. Last but not least, it is c. So if we zoom in on the diagram, here to here, this is 1 meter. Here to here is 10 meters. So in total, this point here is actually 11 meters itself. So therefore, my c value is equals to 11. So let me just write that down. My c value is equals to 11 meters. So therefore, the function is y equals to 10 sine bx. Okay, so b is 1 over 20. But in this case, instead of writing 1 over 20x, okay, we just ask ourselves what is actually the variable here for the horizontal axis. This should be the t seconds. Hence, instead of bx is bt. So here is b, 1 over 20 times t plus the c value, it is 11. What you can actually write it, if you want to rewrite the brackets as t over 20 plus 11, it is also okay. Now, try 22. They ask you to refer to the Ferris wheel with a radius of 30 meters. Okay, so basically you just have to change certain values right from the example itself. So what I did down here is this, I copied it out. Okay, so they say that the radius now becomes 30. So let me just change a few values here and there. So this value here is actually 30. And this value here is equals to 30. Okay, straight away you can say that the a value is equals to 30. Next thing is this, I know at 30, the bottom of the wheel is 2 meters above the ground. So here to here is 2, which means at this point here is 32. So my c value itself is 32 meters or 32. Last but not least, okay, they say that it makes one complete revolution. One complete revolution means one complete cycle, and in this case, one complete cycle is 60 pi seconds. So let me just change this value here to 60 pi. So as we know, period is equals to 2 pi over b. So what we have down here is this, the period is 60 pi equals to 2 pi over b. So my b value is equals to 1 over 30. Hence, if I put everything together, okay, what we have is y is equals to 30. Okay, let me just erase this. Sine of bt, so it's 1 over 30 times t, so it's t over 30 plus c, which is 32. If you want to see the explanation that the book actually gives, this is the explanation itself. I will now move on to example 23. Example 23 is based on historical data. The average daily temperature of a city in June varies from a low of 24. So if you look at my diagram, I've already drawn the low of 24 over here and a high of 31 degrees. So they say that, right, the average temperature can be modeled by a sine graph. Okay, then b and c are constants and t is the time after 9. So they say explain why a is 3.5 and b is pi over 12. So now what we have here is this. To get my amplitude, my maximum is 31, my my minimum is 24. So I want to see, right, how far this distance is, the displacement from the central line here. So what I can do down here is this. I can actually, one way for me to do is I just minus it out. Okay, so I take max minus min. So the max minus the min divided by 2, I can get this value here. So I will take, right, my a value is 31 minus 24 over 2. So it is 3.5. Another way of finding a is I find the midpoint. Okay, so I find the midpoint of 31 and 24. So the midpoint is 31 plus 24 divided by 2. What I get here is 27.5. So if I know that the midline is 27.5, I can take 31 minus 27.5. I also get 3.5. So my A value is also 3.5. So it depends on how you want to look at it. Of course, this working is a lot simpler, but it depends on how you understand this. Now, for me to get my B value, so again, okay, we are trying to find, they say from the max to the min, okay, is from 3 a.m. to 3 p.m. So if you just count, 3 a.m. to 3 p.m. is actually 12 hours. Okay, like this, it's actually 12 hours. But 12 hours is not one complete cycle. Okay, so one complete cycle is another 12 hours. So here to here is the crest to the trough, the max to the min. Okay, that's 12 hours. So as I explained earlier, if I want to get to the maximum value again, I have to put is from the crest to the crest. So it is, the period itself is 24 hours. So if you remember the formula itself, period, okay, is equals to 2 pi over b. So my period now is 24 and 2 pi over b. So my b value is 2 pi over 24. It is pi over 12. Okay, hence I've shown that A is 3.5 and B is pi over 12. So now, lastly, to find my C value, I actually showed you how to find a C value just now. So actually, it's just 27.5. It's actually the midpoint between the max and the min. So what I get right is actually 27.5 here. Okay, so part 2, C is 31 plus 24 over 2. What I get here is 27.5. Okay, now try 23 based on historical data. Okay, it's the same question. Okay, explain why A is 7.5 and B is pi over 12. So you can pause the video now and try 23, and then we'll carry on in 3, 2, 1. Okay, I've drawn the diagram here. So now they say that the max is 10, the min is -5. So if you want to find, okay, the A value, explain why A is 7.5. So what we can do is, the simpler way is to take the max minus min divided by 2, it is 7.5. If not, I can find the midpoint, okay, the midpoint or C. Okay, my C value is 10 plus -5 divided by 2. It will give me 5 divided by 2, it is 2.5. So actually, what you can say is that this line here, okay, is equals to 2.5. Therefore, my A value is a displacement from the midline. So my A value is equals to 10 minus 2.5, it is 7.5. But if you present your working as max minus min divided by 2, you get 7.5. Next thing is this, they say that from the high to the low is 12 hours. So as you have seen in my diagram, from the high to the low, this is 12 hours. But from the min to the max only represents half a cycle. So if I go down to another cycle, here to here is another 12 hours. So in total, the period is equals to 24 hours. Knowing that, I can say that 2 pi over b equals to the period 24. B is pi over 12. Hence, A is 7.5 and B is pi over 12. The C value is the midpoint, as I have already calculated for you, is equals to 2.5. Okay, example 24. This is the last example, alright, for today already. So what we have is this. A mass is attached to a spring and put down to position C from its equilibrium position B and then release. The mass will bob up to position A, and assuming the mass never loses energy or momentum. Okay, why they say this is because if let's say it loses, okay, slowly, it will get shorter, and shorter and shorter and shorter. Okay, this is what happens in real life, but in this case it's an ideal situation, so it will keep going on and on with that perfect sinusoidal curve, which is not possible in real life due to things like friction and all. Okay, so now it can be modeled by this: d equals to -5 cosine pi over 2t. So it's given down here. So the first question they ask you is this: what is the how far is C from B? Okay, as we know, D is -5, so this is 0, this is -5. The amplitude, right, itself is -5. So the distance between B and C is actually itself 5 cm. Straight away I can say that the distance is 5 cm. Now, part 2. How long does it take for the mass to go from C to A? So if you look at the graph, from C to A is down here. But we do know, okay, that period, okay, is equals to 2 pi over B. In this case, if you look, the B value is pi over 2. Where do I get it? I get it from here. So 2 pi divided by pi over 2. So what I'll get here is that the period is equals to 4 seconds. Okay, so I made a mistake with my labeling here. Here to here it is 4 seconds. So if we know that the period is 4 seconds, alright, so it says here that you want to go from C to A. Okay, see, if I know the period is 4 seconds, that means from A to C, then C to A again is 4 seconds. But the question now wants, how long does it take to go from C to A? So this is actually half of 4 seconds. This is the complete 4 seconds. So C to A is actually just 4 divided by 2. It is 2 seconds. Hence, okay, time taken is equals to 4 divided by 2 is actually 2 seconds itself. Okay, part 3. How far is the mass from B when t equals to 2.5? So I do know that the distance, okay, from B is given by d equals to -5 cosine pi over 2 times t. So I ask you, how far is D when t is 2.5? You substitute cosine pi over 2 times 2.5 like this. Use calculator, ensure your calculator is in your what I call radian mode. You should get the value of 5 square root 2 over 2 cm. Okay, for part 4 itself, what are the 2 earliest times when the mass is 1 cm above B? So basically what they're asking you is 1 cm above B. If I draw down here, okay, this is, let's say, 1 cm above B. So they want the times here, here, and here. So they want to find what is this time, what is this time here, and what is this time here, T3. So what I can do down here is this, T1, T2, and T3. So basically they ask you what is the time, solve for T when D equals to 1. So I have -5 cosine pi over 2 t equals to 1. Okay, the distance is 1. So I have cosine pi over 2 t equals to -1/5. So if I try to find my reference angle, let me just cut and paste all of this. Okay, so now I will find my reference angle. Alpha is equals to inverse tangent of 1/5. What I get is my reference angle is 1.3694 radians. Okay, what am I doing here is, where is cosine negative in the second quadrant and in the third quadrant? So my alpha value will be here and here. So in my second quadrant and third quadrant, so pi over 2t is equals to this angle here, pi minus 1.3694, pi minus 1.3694, or pi over 2t equals to pi plus 1.3694. The angle I'm looking for is this one. So if I solve for t in both cases, what I get is, in this case, t is equals to 1.13 seconds, or my t value equals to 2.87 seconds. Hence, the earliest times are 1.13 seconds and 2.87 seconds. And this concludes chapter 11.6, and thank you for